Hello and welcome to my introduction into biophotonics diagnostics and the things we do. Biophotonics Diagnostics is a quite young member of the Biopod network, and we are glad to be in this network, and we are looking forward to a lot of interesting collaboration projects maybe that come up out of this network. But today I would like to give you an insight in the things we do, especially in the spectroscopic part of process analytical technology, and with the focus of machine learning data analysis. This is the main focus we work on. Who is Biophotonics Diagnostics? Biophotonics Diagnostics is a spin-off of the Leibniz Institute of Photonic Technology and is located in Jena in Germany. And with the institute in background, we have a broad knowledge in spectroscopic technology of over more than 20 years. And the background ranges from the hardware setup to design of experiments to the data analysis at the end, especially in complex topics and with a focus on Raman technology. But we are not limited to that because the knowledge is much broader than just for this single technology. And we offer services and software for the data analysis, and we use machine learning algorithms to analyze the data so we can deal with real big data sets and real complex data sets that comes from the different measurements. The example I bring by to show you how easy it is to analyze a complex data set from spectroscopic measurements is a bioprocess with E. coli as organism, and the products and byproducts that were produced during this process were analyzed by a laboratory analysis with HPLC, for example, to get the real concentration of the components. As well, each sample that was taken every hour was also analyzed with Raman spectroscopy. And some runs we did also inline measurements directly in the process by putting the sample probe into the bioprocess via a viewport, and also every 1 hour we took a Raman spectrum from the current mixture in the bioreactor. And all the data were taken to analyze by our software. As Raman spectra needs the most complex data analysis pipeline, our software is called RAMANMETRIX. And you see on the left-hand side of this slide the necessary data analysis pipeline for Raman spectroscopic data with a lot of pre-treatment, pre-processing, and model building steps. And we do not need to go into the details. This complete pipeline was taken to software concept, and on the right hand side you see the user interface architecture of the software, and I would like to show you some details of that software in the next slides, so that you will get an insight how easy it is to deal with that data analysis process. The first screenshot I would like to show is that where the process is starting with importing the data. You see on the left hand side of the software some buttons to start the imports and the analysis pipeline with treatment, pre-process and analyze. And in the upper part of the software, there are the single steps of the whole pipeline with more details that can be set and run for the analysis step by step. And here you see the spectra taken from that bioprocess, and you see the broad range of spectra intensity coming out during the complete run of that bioprocess. If it is needed, despiking and also wave number calibration can be done. I do not show this with a screenshot. Here you see the next step. It's the background correction, baseline correction, where you can choose from different algorithms to do with. And there are also some settings that can be made to optimize the situation, how the algorithm is working. And in the lower part, you see the corrected spectrum of our example data set. The next step is normalization that is needed for a good data set for applying machine learning models. And within this step, some settings can be made to use a special area, for example, or to exclude some area of the spectrum as well. The normalization type can be chosen from different algorithms. And in the lower part, you see the normalized spectrum of our data set. Now we come to the part of the machine learning algorithms, where you can choose from different algorithms for classification, for example, or regression if you have a quantitative analysis to do, or even clustering is possible to choose from. Here in our example, we use a regression algorithm. It's an PCA-LM, that means principal component analysis, linear modeling that we have chosen. Some settings can be made to optimize that algorithm, and then you can start building the model. The result is shown here. In the upper part, you see the confusion table that contains, for example, the real value of that component taken from the HPLC analysis and the predicted value with our algorithm. And in the lower part, there's a regression plot that shows the real value on the x-axis and the predicted value on the y-axis, and it shows a quite good fit in this case. To see how the power of the machine learning algorithm is and which part of the spectrum has the most impact to the result. Additional graphs are very helpful. Here is an example, especially in the lower part. The PCA loadings shows the impact of the wave number ranges. As higher or lower the value is, as more impact of that range has to the result of the machine learning algorithm. As additional example, here you can see a screenshot of a data analysis with NIR data set and a classification of material samples. And you can also see that there is a quite good result in analyzing this NIR spectra. The previous slides I was showing you were to show how easy it is to go through the whole data analysis pipeline step by step. And this has a more R&D character because the focus is to find out the best pipeline settings and the best algorithm to analyze your data. For using such a model in routine data analysis, we do not need the user interface. We have to integrate the software into other environments, in other architectures. So this is what I want to show you in the next slides. In this picture, you see in the upper part the steps of the analysis pipeline we was going through step by step, and it's for building the artificial intelligence model. And in the lower part, it needs to go through the complete pipeline again, but automatically with that built model. It takes the live data imported to the RAMANMETRIX backend, doing every step of the analysis pipeline, and at the end applying the model to do a prediction of the class of the sample or the quantitative result. Integration in other systems with RAMANMETRIX is quite easy because RAMANMETRIX has a core backend that is doing all the computational work, and it communicates with different interfaces to the RAMANMETRIX user interface or to other applications via an API interface. The application interface can also be customized for special user needs or integrated into other device software. Coming to the end of my introduction, I would like to summarize what we offer and what we are looking for. We offer software and modules for data analysis on a license basis, and we also offer consulting and support in data analysis and spectroscopic application on your special needs. And we are looking for partners to do some challenging projects with spectroscopic data and process analytical technology applications where we can challenge our data analysis software. And we also look for partners for special research and development projects to go to new approaches and technologies. Yeah, and so I thank you for your interest in our things we do, and hopefully we can have a chat together and go deeper into some details. Thank you.